Good evening, everyone. Welcome to the last live interaction session, the summary session for the course Polymer Concepts, Properties, Uses, and their Sustainability. So, as usual, let's just wait for a few minutes for others to join before we begin our session for today. So, let's begin our session for today. Let me just share my screen. I hope my presentation is visible and I'm audible. So, let's start our session for today. I welcome everyone to the last live interaction session for the course Polymers Concept Properties Uses and Sustainability. This course is offered by Professor Abhijit Deshpande sir from the Department of Chemical Engineering IIT Madras under the NPTEL program. Myself Pratyumnan, a PhD research scholar from the Department of Chemical Engineering IIT Guwahati, Assam, is responsible for conducting the live interaction session for this course every week for the July-November 2025 session. So far we have come across 12 live interaction session and we have completed the course. So this particular live interaction session will be more of kind of summarizing what all we. Second. Yeah. So sorry, there was a internet disruption. So let me just share my screen once again. So I hope my presentation is visible and I am audible. Okay. So so far we have come across around 12 weeks for this course, and we have learned a lot about the polymer concept, properties, uses, and sustainability. So if you remember, in the very first week we discussed about what are polymers, why polymers are so common, and then we discussed some of their basic properties, uses, and sustainability. Then later we went more towards understanding different types of polymers, different your copolymer. So in copolymer we saw many different classifications such as random copolymer. Then we saw the concept of block copolymer. After that we saw alternating copolymer, and once that was completed we discussed about the mechanics of how these monomers form either the random copolymer or the alternating copolymer or the block copolymers. Then we discussed about the polymer physics part, so where we discussed about the random walk model, and then we also discussed about the concept of polymer as an ideal chain. So I hope you guys are able to recollect all those concepts, because these are polymer physics and we have learned this probably in week 2. So almost 10 weeks have gone past that, but still I hope everybody is able to recollect. We discussed about the concept of polymer as an ideal chain. Then we discussed about Stokes-Einstein relationship, the radius of gyration concept. So any idea or any kind of like um, anyone remembers anything on what we discussed during that time about polymer as ideal chain? Any small hint anyone can give? Okay, so I hope you guys actually go and then recollect those concepts, because they are very important as we discuss about polymers in detail. Then we discussed about polymer crystallization. How does the crystallization of polymer happens, either by cooling it down or either through solvent evaporation. Then we discussed about the different type of polymer chain crystals that can form. One is the extended chain crystal and another one is the folded chain crystal. And then we also saw the reason why the folded chain crystal is one of the most common type of crystals that is available out of the macromolecules. Then we discussed about how polymer crystals can be formed from the polymer melt. Then we went on to discuss about the kinetics of the crystallization, their interaction parameters. We discussed about the polymer relaxation process. So what is the relaxation process in case of a polymer, and how does it varies in case of crystalline solid, amorphous solid, and then in case of polymer. We discussed about the main concept of glass transition in the polymer. So I hope everyone is able to recollect the basic definition of glass transition. It's basically where the polymer moves from a glassy state to rubbery state, or you can also say that the polymer tends to exhibit flow like behavior. And then we discussed about the mechanical responses of the polymer: uniaxial, biaxial, what do you actually mean by brittle, and what is the meaning of toughness of a polymer. So the ultimate tensile strength concept, all those things we have discussed about the mechanical properties of the polymers in detail. And then we discussed about the rheological models of the polymers, specifically something that we discussed in the last to last live interaction session. And in the previous live interaction session that we had yesterday, we discussed about the concept of microplastics research, microplastics and the biodegradable polymers. So we discussed about how microplastics is a major cause of concern these days, and what are the questions that are yet to be solved in case of the microplastics, so that their contamination can be reduced, and ultimately that can benefit the human being, because their accumulation in the environment is directly impacting our health. So how to handle polymer plus or how to handle plastic waste safely without much damage to the environment is a major question that is left out with us now, because we have come so far in the polymer, in using these polymers, that it becomes very difficult to cut down the use of polymers. However, we can go with strategies where we are able to make these polymers degradable, or try to synthesize polymers which are biodegradable in nature, but at the same time have these properties as that of the conventional ones. So these are some of the things that we discussed in the last live interaction session, and also we discussed about biodegradability as such, about what are the different types of ways in which the polymers can be degraded. So we discussed about UV radiation, then we discussed about the thermal fluctuation, mechanical fluctuation, and in biodegradation we talked about chain breakage as a first concept, and second concept as how the use of enzymes by these microorganisms break the polymer chain into simpler fragments which can be used as a food source for them. Then we discussed about what are the two things that we need to keep in mind while talking about this biodegradation. One is basically the rate of biodegradation. The second one is that the intermediate products that are generated during this process should be non-toxic in nature. We also discussed about the types of factors that affect this biodegradation. So till last class we saw for that, and that concludes our session on how polymers are so common, what are their properties, and what are their properties that makes them so common in use, and if they are so common in use and then they are going to be disposed, how to make the process sustainable, or how to make polymers sustainable. So this was the entire kind of um, things that we discussed in the 12 live interaction sessions, as well as in the course, in all the across the 12 weeks. This is what we have discussed. It's so again, whatever I have just mentioned something that comes to my mind while talking about polymers. So I encourage everyone to actually go through the entire course once again so that they can have a better understanding on the concepts that is discussed in the course. So apart from that, today we do not have much to discuss, but we have certain problems to solve. So this are some of these questions which we wanted to solve in the previous sessions, but unfortunately due to time constraint, we were unable to progress further. So I want to take up with those questions, and I hope everybody will be able to answer those questions now. So it should not be of so it should not be of much difficulties, hopefully. So let's start with the first question. So this was the question that we were discussing yesterday. So here you have to pick out the correct source for different size of plastics in the environment. Now you have four different options. So the question that I asked was in the last live interaction session is, what do you mean by the primary and the secondary source of plastics in the environment? So did anybody go through that? What is actually the meaning of primary and secondary sources of plastics? Yes. Anyone? What are primary and secondary sources of plastics? Just a second. So based on that only this classification is actually centered. So if you know what are the primary and the secondary source, then probably this question should not be much difficult. So primary as well as that of the secondary sources or the plastic is nothing but in case of the primary source, it typically talks about the material that is actually made up of. Primary source are from where the materials are actually made, whereas if you see the secondary source, it typically refers to the material properties. So based on that, now you can actually tell me which one can be primary and which one could be primary plus secondary. Yes, anyone? So macroplastics will be only primary, right? Because they are actually the materials that are made. They are the primary source is basically the one from where the material is actually made. So macroplastics is going to be primary, and meso micro other types of plastic, mesoplastic, microplastic and nanoplastics is going to be primary plus secondary. So option B. So I hope there is no doubt related to this question. If you have, then you are welcome to ask me, or otherwise we can move to forward to the next question. So the next question is, identify the trait test among the following techniques of rheology. So there are totally four different types of rheology techniques, and all these techniques are something that is based on to understand the flow behavior in case of fluids. But which of the following here is a trait test? Is it extensional rheometer, or is it U-tube viscometer, or is it melt flow indexer, or is it rotational rheometer? Yes, anyone? Which one of the following techniques is a trait test for rheology? Please keep in mind the word trait test. I think we discussed about trait test for hardness, if you remember. So there it was something. There it was like nano indentation was the trait test for hardness. So here, likewise, what will be the trait test for rheology? This we have actually discussed. Actually, only one of the following is a trait test for rheology. All the other thing that is there for rheology, they are kind of what do you say, more often of the laboratory technique to understand the rheological behavior. Yes, anyone? So it should be the melt flow indexer, right? Because that is the only trait test that we have discussed for the rheology. If you see the other kind of techniques, they are for rheology, as I said, but they are not the trait test. So they don't actually uh, like the laboratory test usually discusses more about the material properties, whereas the trade test checks whether that particular property is commercially feasible. So if you see in case of rotational rheometer, the rotational rheometer is specifically used to find out about the material's viscosity and other rheology parameters like stress and strain, and how they vary with, and its variation with the shear rate, temperature, and frequency. Whereas if you see for YouTube viscometer, it is typically only to determine the kinematic viscosity of the fluids. So it will be like a U tube. So the tube will be in the form of U shape, and that is usually used to determine the viscosity of the fluid. That is it. So that's what we call as U-tube viscometer. Then we have the extensional rheometer. So what it typically does is it tries to determine the extensional viscosity by stretching the polymer melt. And measures that particular deformation. So the melt flow indexer, if you remember the melt flow index concept, so how we discussed about the melt flow index and its relationship with viscosity and molecular weight, if I'm not wrong. So we discussed the one particular question about how does the melt flow index varies with viscosity. So it is inversely proportional, right? We discussed about this concept of melt flow index when we were discussing about polymer processing operations. We discussed how this melt flow index will vary with viscosity and molar mass. And specifically, we also discussed what is melt flow index. Anyone? Melt flow indexer is used to determine melt flow index. But what is the significance of that melt flow index? So melt flow index is nothing but it's an industrial measure to see this polymer's flowability. So it's a kind of a measure which basically measures the amount of polymer melt that flows out of a die under a standard mass in a given time. I hope everyone is able to remember that. The measure of the amount of the polymer melt that flows out of the die under a given time is called as melt flow index, and this varies inversely with the viscosity and molar mass. So melt flow index is inversely proportional to viscosity, as well as melt flow index is inversely proportional to molar mass of the material. So that is related to this question. Now let's move on towards next question. That is a quite simple one. Among the options given, identify the correct pair or pairs of catalyst and co-catalyst that forms the Ziegler-Natta catalyst. So Ziegler-Natta is a very common catalyst. So here we need to, so Ziegler-Natta is a very common catalyst and it's a trade name, like uh, it's not a chemical name. It was named after the scientist Ziegler-Natta. So which of the following pair of catalyst and co-catalyst together forms this so-called Ziegler-Natta? So that's what we have to answer here. So which one of the following pair is the pair forms the Ziegler-Natta catalyst? Yes, anyone? This is something that is very common, Ziegler-Natta. So anyone? Okay. Let me just check the internet. Sorry, there was an internet connectivity issue. So yeah. So we were here in the question number three. Which of the following pairs of the catalyst forms the Ziegler-Natta catalyst? First of all, what is the use of this Ziegler-Natta catalyst, or in which or where do we use this Ziegler-Natta catalyst for the production of? So Ziegler-Natta catalyst is typically used to produce high density polyethylene, low density polyethylene, and in majority of the objects, specifically the high density and the low density polyethylene. And this is and since this plastic is commonly used, so it's almost used in every product that we commonly used in everyday life. So the Ziegler-Natta catalyst is used mainly in the production of high density and low density polyethylene. So now, based on this, which one of the following is the correct pair of catalyst and co-catalyst? So actually there are two options here. So I'll give you the first one. The first one is TiCl3 and AlCH3CH2 twice Cl. Now which one will be the second one? It is VCl4 and AlCH3CH2 twice Cl. So these are the catalyst as well as the co-catalyst that forms that together actually is called as a Ziegler-Natta catalyst. So please remember this because Ziegler-Natta catalyst is a very common catalyst which is used for the production of many commonly used polymers. So we need to actually know what that Ziegler-Natta catalyst is when we are, I mean, when we know the name, we are supposed to know what are the constituents of that particular catalyst as well. So have this in mind. Now let's progress to next question. Again, if you have any doubts in related to what we have discussed so far, either in the discussion or in the three questions that we have discussed, please let me know before we progress for solving the problems like numerical problems. So let's progress towards solving the next question. So question number 4. In cone and plate viscometer, the rate of strain is related to the rate of speed of rotation of the cone. Which one of the following relationship is correct? Here omega represents for omega is basically the speed and alpha is the angle between the cone and the plate. So in case of this viscometer, there are usually multiple types of geometry. So one is the parallel plate one and another one is the cone and plate. So in this case, the cone, that angle, the vertex or the angle between the cone and the plate will be actually very small. So now based on that, we need to say what will be the relation. I mean, it is given that rate of strain is related to the speed of rotation of the cone. Now based on this, we have to predict the correct relationship. So how do we go about solving this problem? Think from the fact that it is given how to correlate the rate of strain and the rate of speed of rotation of the cone. So rate of strain can that be written as gamma dot? So if this is the rate of strain, now this rate of strain is related to the rate of speed of the rotation of the cone. So that means there is this relationship. So is equal to omega by tan alpha. So as I said, for a cone and plate viscometer, the angle between the cone and the plate is going to be very very small. So for small values of alpha, tan alpha can actually be approximated as alpha itself. So when the value of this when the value of a particular quantity of a particular variable is going to tend to 0 or is going to be very very small, then the tan and sine of that particular angle will be equal to that angle itself. So based on that, we can write for small values of alpha, tan alpha will be approximately equal to alpha. So based on this, I can rewrite this equation as omega dot, that is your rate of strain, is equal to rate of speed of the rotation of the cone by tan alpha. Now this equation will change out as, since tan alpha is approximately equal to alpha, so I can write it this way. So omega dot is equal to, sorry, gamma dot is equal to omega by alpha. So that relationship is what we want to actually determine here. What will be the relationship of the rate of strain and the rate of speed of rotation of the cone? So that is nothing but it is equal to omega by alpha. So that this is the relationship. So if anyone has any doubts, you are welcome to ask me, or otherwise we can progress for the next question. So if there are no doubts, then let's progress towards the next question. So this is something that I had asked people to solve. So something that we discussed during the live interaction session of week 10. So here what we have is we perform DMA analysis of polystyrene sample, and it has a TG of 100 degrees Celsius. when measured at a frequency of 1 hertz, and it shows the damping at 110 degrees Celsius. Now, if the same measurement is going to happen at 104 hertz, then what will be the peak temperature? So, I told that we need to use the William Landau Fleury equation. Now, here we know the value of C1 as 17.44, C2 as 51.6. Now the question is how to calculate the value of TR is 100 and T is 110. So how to calculate the value of alpha T, that is your shift factor. Oh, sorry. So here we know, do not, you know the value of TR, that is 110, but you have to actually calculate the value of T. But before calculating the value of T, you should know what is the value of alpha T. Here alpha T is not given straightforward, so the question is how to calculate the value of alpha T. Did anybody solve this problem? Alpha T value. If you know that, then then we can substitute that and then calculate the value of T. Try to think about how to use the parameter like the frequency parameter that is given in the question. So can we write it this way? I'm going to, oh sorry, I'm going to make a separate alpha T, that is your shift factor, can actually be represented or expressed in this form as well. Alpha T equals to F by Fr. So that is your frequency at which you are going to measure to that of your reference frequency. So here our reference is basically based on that damping peak what is observed at 110 degrees Celsius. So if the damping peak is at 100 degrees Celsius, 110 degrees Celsius, then it was actually measured at a frequency of 1 hertz. So our FR is going to be 1 hertz and F is going to be 104 hertz. So then the value of alpha T will be 104 by 1, that is equal to 104. So this is your value of alpha T. Now you need to substitute this in this WLF equation. So log of 104 is equal to minus C1 value is already given, minus 17.44 times T minus TR. So T is something that we need to calculate, the peak temperature if the measurement is made at 104 degrees Celsius. So T minus 110 by C2 value is given as 51.6, and keep in mind that the value of C1 and C2 are actually constant, so their value will not change. For a particular polymer system, these values are going to remain constant. So T minus TR, so T is something that we need to find out, TR is 110. So what will be the value of log 104? Going to be 2.017 times T minus 110. So if you cross multiply, then it will be so if you open the brackets, then 104.07. So now we need to just rearrange this equation and calculate the value of T. So 2.017 plus 17.44 T equals to 1918.4 minus 104.077 plus 221.87. Sorry, so 17.44 plus 2.017 is 19.457 times T equals to 1918.4 minus 104.077 plus 221.87. Oh, 1918.4 minus 104.077 plus 221.87. So 2036.193. Now T value will be equal to this divided by 19.457, 104.65. So somewhere our calculation answer is not matching. Just a second, let me use my personal calculator to recheck the calculation. Mhm. So this is the answer. Let me just check once because the options are not actually matching with them. So I need to check this question once. But as per the calculation and the method, this is the answer. But let me just clarify this once and then I will come back. So as per our calculation, the answer is T equals to 104.65 degrees Celsius. So this methodology is fine, but I'll just look at what is there anything that we have missed out. So meanwhile, if you have anything to ask, you are welcome to ask me now, or we can move towards next question. So any doubts to ask anyone? Okay. So I'll get back on that question after some time before this session ends. So the next question, let me read out loud, and I guess this question is something that we have discussed previously also in the last or last to last live interaction session. So here the question is, for a polymer solution, the dependence of viscosity on shear rate is described by a three parameter carreau model. Again, this we discussed in yesterday as well, that when the carreau Yasuda model is, upon subjecting it to a constraint, you get the cross model or the three parameter carreau model. That particular constraint is that the infinite shear viscosity or high shear viscosity is equal to 0, and we also saw the condition in at which the high shear viscosity or infinite shear viscosity will be 0. So based on that three parameter model, the three parameter model, sorry, here is described as eta equal to eta naught times 1 plus delta gamma dot whole cube, the entire whole power n minus 1 by 3, where eta naught, lambda and eta, sorry, n are the three parameters of the model. All the three parameters are positive quantity. It is written that if the shear rate is increased from 0.1 second to 200 second inverse, 0.1 second inverse to 200 second inverse, the viscosity of the polymer solution is going to decrease by a factor of 20. Now for a polymer solution with the value of n equals 0.4 and eta naught equals to 50 Pascal, calculate the value of the lambda parameter. So what is the significance of the value lambda? This we also we saw in the last session. What is the significance of the value lambda? So gamma dot is nothing but it is the strain rate or the rate of change of strain. Eta and eta naught is nothing but zero shear viscosity. What about n and lambda? Or how to solve about this question? What is the significance of the value lambda? Oh. Oh. Uh-huh. Oh, thankfully that internet was restored. So it almost like took like 10 minutes for the internet to get restored. So okay, let me just share my screen once again. Let's continue where we left off at around 6:15 or something. So I hope my presentation is visible and I'm audible. Okay, yeah. So we were there in this question, question number 5. So let me just read it out once again. So for a polymer solution, the dependence of viscosity on shear rate is described by the three parameter carreau model, which is given by eta equals eta naught times 1 plus delta gamma dot, which is your shear rate, the whole power 3, the entire whole power n minus 1 by 3, where eta naught, lambda and n are the three parameters of the model. So as we have seen this even in the last class, that carreau yeshuda model can be reduced to a three parameter model by applying some constraints. So all the three parameters that are here are positive quantity. As the shear rates increases from minus 0.1 second inverse to 200 second inverse, the viscosity of the polymer solution decreases by a factor of 20. So based on this given data, it is also given that the value of N is zero point 0.4 and eta naught is going to be 50 Pascal. That is your zero shear viscosity. Now based on these data that is available, we are asked to calculate the value of lambda. So I was asking, what is actually the physical significance of the value lambda? So that's where I think that internet got disconnected. So what is the physical significance of the value lambda? Yes, anyone? So this is something which we discuss. It's about that. What do you say? It's a kind of that region transition. If you are able to remember. So lambda is nothing but it is characteristic time. So characteristic time of how quickly the fluid's viscosity transition from the zero shear plateau to the power law region. So that is what is the significance of the value lambda. We saw this. What is the value? What does n represents? What does lambda represents? What does eta naught, eta infinity represents? So based on that, we are and here we are given the model, the carreau model, as that expression is given, so we are supposed to use that expression to calculate the value of lambda. So this is something exactly very similar to what we discussed in the week 11 live interaction session, so where we are given with the same type of a problem, it's just that the data is going to be different here. So any answers from anyone? So let's solve this as well, but this time I'll solve it a bit more faster because we have solved these kind of questions prior. So just, oh, so I hope if you have not solved it yet, please solve it along with me. We have solved this question before itself, so let me just copy this three parameter model. Okay. So now we know this one, and it is written that as the shear rate increases, the viscosity of the polymer solution is going to decrease. So I'm going to just copy this equation. So at shear rate of 0.1, so this will be 0.1. This is at shear rate of 0.1 second inverse. Now the same expression will, instead of zero point 0.1, it is going to be 200 cube. So this is at a shear rate of 200 second inverse. Now it is written that other values are given. Apart from that, it is also mentioned that um, the viscosity of the polymer solution decreases by a factor of 20. So eta is going to be, eta by eta dash is going to be equal to 20. So if we, because the viscosity is decreasing here, so eta by eta dash will be 20 and it's a factor of 20. So then it will be um, so 0 0.4 minus 1 will be minus 0.6 by 3, so that is minus 0.2. So I'll change it here as well. So it's going to be 20 equals to, divided by 8 times 10 to the power 6 lambda cube whole power minus zero point 0.2. So I can just simply write this way as well. So whole power zero point 0.2. So if you divide, I mean if you make it to the power point 0.5, sorry, make it just take this power point 2 to the other side, then you will be getting, we do not have space. So then this will be, it will be in this form. So it will be like 20 power 5 times 1 plus this factor. So what is 20 power 5? It should be 32 into 10 to the power 5. But anyway, let me show that. Hmm. So it will be like, this one will be equal to lambda q. So zero point 0.4 is lambda cube. So lambda value will be 0.736. So this is the value of lambda. So since it's a characteristic of time, it has a SI unit of seconds. So I have got the value of lambda as 0.736. So if there are, and since this calculation is quite tedious, so if you have any other answers, you are welcome to share it with, share it here to check, if there is any mistake with the calculations. Yes, anyone with any other answers? Okay, so let's, if no doubts or if no other answers, then let's move on towards next question. I think this is a very simple one. So this should not be of much difficulty. But again, if you have any doubts related to the last questions, please let me know. Till that time, let me read out this question. The glass transition temperature of poly 2,6 dimethyl paraphenyl oxide PPO is 206.8 degrees Celsius and the glass transition temperature of polystyrene is 90 degrees Celsius. What will be the Tg, that is glass transition temperature of a 50-50 weight percentage miscible blend of PPO and PS? So calculate that value of Tg. So we have previously calculated the Tg for systems like copolymer systems, but here it is not a copolymer but it is going to be a polymer blend. So in that case, how do you calculate the glass transition temperature? If you see for copolymer, the relationship was very simple. It just kind of you can say addition of their respective contribution. Let's say 50 percentage of some polymer has certain Tg, then we just multiply that 0.5 times Tg of A plus 0.5 times Tg of B, that is the Tg of the new copolymer system that is obtained. But here it is going to be a polymer blend, so the equation is going to be a little bit different. But again, this is something that we have learnt in this course, so since it's just about a formula, I hope it should not be of much difficulty to solve. So please take some time to solve this question and then let me know the answer. Anyone with any answer? Or how to proceed with solving this problem for calculating the glass transition temperature of a polymer blend?
Hello.
Yes. Yes, 400 and okay. So somebody has told somewhere around 400. I think probably network connectivity issues from their side. So let's start solving this problem. So in case of, as I said, in case of, yes, 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 hello. Okay. So okay, let's solve and check. So okay, let's solve the question. So for this we use the Fox-Flory equation or Flory-Fox equation. I think it should be Fox. So if you use that, then it would be 1 by Tg equals to weight of PPO by Tg of PPO plus weight of PS by, oh sorry, by Tg of PS. So now you just need to substitute and you will be able to get the value. So let's do it in, so actually since someone told it in terms of Kelvin, let's do it in Kelvin. So Tg of PPO is going to be 206.8 plus 273 Kelvin. So that is 0.8974. Yeah, 479.8 Kelvin. And the Tg of PS is going to be 90 plus 273 Kelvin. That will be 363 Kelvin. Now we need to substitute that in this equation. So 1 by Tg is, weight fraction is 0.5, so it is 0.5 by 4, 79.8 plus 0.5 by 363. So then the value of Tg is going to be 0.5 times 363 plus 0.5 times 479.8 by, oh, 1 by Tg will be 479.8 times 363. So if you calculate this, then So the Tg value is around 413.3 Kelvin. I guess this is what was the answer that was told to me. So it's exactly correct. So that is the value of the glass transition temperature of the miscible blend of of PPO and PS. So this is what so this equation is what something that is going to be different if you are going to calculate the glass transition temperature for a copolymer and or that of the blend. So over there it's just going to be simple additive of the two fractions, but here the equation is going to be different in case of polymer blend. So I hope everyone got this answer. If you have any doubts, you are welcome to ask me, or otherwise we'll go. So the last question is, the propagation step of free radical copolymerization is represented by the following reaction steps. So you have four different reaction steps and you have two monomers M1 and M2, and M1 star and M2 star are the active radicals of M1 and M2. Kij, where I and j equals 1 and 2, represents the rate constant at each steps. Now it is given that the reactivity ratio of M1 and M2 are expressed as R1 equals K11 by K12 and R2 equal to K22 by K21, and the feed mole ratio is F, and F is expressed as the ratio of M1 by M2, where these are the concentrations of M1 and M2. Now with this details in our hand, we are supposed to calculate the probability of reaction P2, that is M1 star plus M2 gives M2 star. So that particular reaction's probability we are supposed to calculate. So this is something that we saw during this copolymer um, while discussing about copolymers. So think and then let's see how to solve this. So how do you first express the probability of reaction P2? Can we write it this way? Probability of reaction P2 is, so I'll write it as P of P2, so that it is, for clarification, that it is probability that we are going to talk about. So it will be P2 by P2 plus P1. Now P2 rate of reaction can be written as K12 times M1 star times M2, and P1 is K11 M1 star M1. So that M1 star and M2 star are going to be the free radicals in the system. So if you just so you know P2 and P1, you can now calculate the probability PP2. So here everywhere M1 star will be is going to be constant. So I think I can directly write it as K1 M1 K1 M2 by K K11 M1 plus K12 M2. So now we know that, so here we are just supposed to now express the equation in terms of R1 and F, known quantities. So if you just divide both the numerator and denominator by K12, what we will get? So P of P2. So divide both numerator and denominator by K1 M2. So in the numerator it will be 1 by 1 plus it will be K11. So let me take a bracket here separately. K11 M1 by K12 M2. So K11 by K12 is given as R1 and M1 by M2 is given as F. That is your feed mole ratio. So that will be 1 by 1 plus R1 times F. So this is the expression, I mean the probability of the reaction P2. 1 by 1 plus R1 times F. So here if you have any doubts you are welcome to ask me. This is the last question. So if you have anything that you want to ask me, you are welcome to do so before we conclude our session for today. In case if you have any doubts with solving of any problems, please feel free to ask me. So if you have no doubts, I think I can conclude the session for today. So let me stop presenting. Okay. So I hope there are no doubts. If you have any doubts, okay. So I thank everyone for joining today's live interaction session as well as all the 12 live interaction sessions that was conducted for this semester. So thank you everyone for joining. So in case if you have any doubts, my mail ID will be available in the presentation which I will be uploading it by tomorrow. So if you have any questions, you are welcome to email me. I thank Professor Abhijit Deshpande sir as well as the NPTEL team for providing me this opportunity to interact with you all on this afternoon. And yeah, thank you everyone. So all the best for your exam. So until we meet somewhere in the next course, thank you and have a good day ahead and all the best for your exams. Thank you.